Good day to our dear panelists, Dr. Leah Haff, Dr. Jean Haff, and Dr. Jocelyn Kong. I am Amy Rose BAYBAY, an MAMT student. I'll be continuing our presentation for a research proposal entitled The Level of Difficulties of Grade 9 Students in Nara National High School in Times of Pandemic. I'll continue with the conceptual understanding. Students who have been helped to learn concepts and can define, recognize, and exemplify elementary ideas are better able to use and combine these ideas in new situations and while learning a new concept. However, many difficulties appear to be due to having too limited a range of understanding. Their understanding may be based on examples which have irrelevant features in common, such as the parallel sides of parallelograms always being parallel to the edges of a page. Understanding is also limited by examples being similar to a prototype, rather than the extreme cases. This is according to Watson in 2009. To be able to decide when and how to use informal or formal approaches and how to use prior knowledge, students need to be able to think mathematically about all situations in mathematics lessons. It has been argued that the use of oral and written communication in mathematics learning should promote deeper conceptual understanding. However, such a change implies major shifts in the teaching practices most teachers use. There is increasing evidence that knowledge of children's thinking is a powerful influence on teachers as they consider instructional change, according to Fenema et al. In 1996, cited by Cotton in 2008. Problem-based instruction is a teaching technique that stems from constructivist learning theory. It is a form of teaching where students are presented with a real-world problem and then given the time and opportunity to solve that problem in order to discover a new concept or practice a newly learned concept. The process of solving an authentic, real-world problem is the avenue for new mathematical concepts to be presented. So let's move to skills in solving math. Those same authors argue that a problematic mathematics classroom is well suited to engage students, show students how mathematicians solve mathematics, and makes mathematics useful and relevant to students. The problem-based process can be completed with the varying degrees of guidance from the teacher. The role of the teacher is to help students along their own paths to find solutions to posed problems. With this type of instruction, the correct mathematical solution is not the only goal. Students also learn valuable skills such as critical thinking, estimation, and mathematical communication, according to Petrick in 2011, cited by Kalman in 2015, page 10. Difficulties in mathematics skills were classified into number fact, arithmetic, information, language, and visual spatial skills. Difficulties in solving math. The students face difficulties in mathematics problem solving due to incompetency in acquiring many mathematics skills and lacking in cognitive abilities of learning. Information skill was found to be the most critical mathematics skills. Although students acquired other mathematics skills, without the transfer of information skill, they could not understand and make effective connection of the information in the problem. Generally, the majority of the students did not acquire this skill utterly. Cognitive abilities in learning, such as the ability to recall, memorize, and perceive, influence the efficiency of problem solving, according to Tambicek in 2010. So showing you here the theoretical framework diagram. So we have the center, the difficulties in solving mathematics problem. And here are the factors. First is the attitudes, the skills, the concepts, and the study habits. So our conceptual framework. So the major concept of this inquiry is focused on the level of difficulties of grade 9 students of Nara National High School in solving integers, fractions, and radicals in the school year 2020 to 2021. So showing you a figure shows how the issue of the study is addressed from how and why the problem started and affects its conceptual understanding. The concern was treated by a scientific process and the results were interpreted by its outcomes. So here's our conceptual framework diagram. So we have here the input, the students' related factors. So we have 3, study habits, the misconceptions, and students' interest. We have also self-perceived difficulty. The lessons in grade 9 mathematics includes fractions, integers, radicals. We have the output through surveying, data gathering, data analysis, and data interpretation, and the process, an analysis of the student's level of difficulties in solving fractions, integers, and radicals as related by their study habits. Review of related literature. So research gathered on analysis pupils' difficulties in solving problem related to fraction by Delechaco in 2013 find out that the performance of candidates in mathematics in primary school living examination has indicated that a considerable number of candidates could not perform correct operations related to fractions. They intended to confuse fraction concepts with whole number concepts. For instance, in questions involving additional of fractions, they were treating numerators and denominators as separated entities. Possible reasons for such difficulties in solving questions related to fraction include lack of understanding of appropriate procedures to apply in solving a problem, the complexity of the task, overgeneralization of procedures, even in situations which are inappropriate. The same is true with integers and radicals. Presenting you our research methodology, starting with the research design. So this study is a descriptive and made use of quantitative methods. The score of the test results administered to the learners will be used primarily to describe the students' level of difficulties in solving integers, fractions, and radicals, which includes tallying of their errors and calculating the percentage of failing scores. Moreover, there will be questionnaires used to gather the learner's self-perceived most difficult topic and the relationship towards their study habits. Our research respondents, so the randomly selected 3 sections of grade 9 students, a total of 60, who will respond the questionnaire given by the researcher a day after a certain test has given about fundamental operations of integers, fractions, and radicals. So focus of this inquiry was the numerous errors of mistakes exhibited by the learners during summative tests, and the researcher would like to connect their errors with their individual study habits and its levels of difficulties. Specifically, it sought to answer the following. Number 1, how many students got a failing score in math test? Number two, what topic did they found most difficult? Number three, what are their study habits in math? Number four, is there a significant relationship between the study habits and self-perceived level of difficulties per topic? For integers, for fractions, and for radicals. For our research environment, this study was conducted where the researcher or one of the researcher is employed as a secondary school mathematics teacher, which is Ma'am Eileen Terania. The school is the Nara National High School in Bayawan City, Negros Oriental, in the grade 9 department. It consists of 164 students with 3 sections, and also 3 sections out of this population were handled by the researcher. So this group of students are randomly selected in terms of draw lots, and only out of 3 sections, we selected a population of 52 to be used for the study. So research instruments. A questionnaire was originally made by the researchers and used as a summative test. This is a 12-item test that assessed students' basic conceptual understanding and procedural skills on integers, fractions, and radicals. There are 6 items for the conceptual understanding and 6 items for the procedural skills. 4 items for every topic. Item 1 to 4 are integers, item 5 to 8 are fraction, and item 9 to 12 are integers. Survey questionnaires were taken as an intervention to assess the learner's level of difficulties. This instrument was validated by a graduate school professor in which difficulties were categorized as very high, high, average, low, and very low. So since the K-12 curriculum program in the DepEd is spiral, it is therefore understood that the topic was already discussed in the lower grades and the concepts are already carried over at the present. Since the topic is solving quadratic equation, the concepts of integers, fractions, and radicals are already part of it, and it was discussed 2 weeks before the test has been administered for 30 minutes to target participants. Then 1 week after, questionnaire surveys were administered to 60 randomly students to obtain their perceptions about the given test. Thank you very much and have a good day.